On today's episode of On.net, we're going to be talking about observability in Orleans with Reuben from the Orleans team. We'll be covering OpenTelemetry and observability in general. Check it out. Hey, welcome to another episode of the On.net show. Today we're going to be talking about observability with Orleans with Reuben, who's on the Orleans team. Welcome, Reuben. Thanks for being on the show.
Thank you. Yeah, I'm excited to be here.
Tell us a little bit about yourself, and then we'll get into the topic.
Sure. So I'm Reuben Bond. I'm one of the main developers on Orleans, and I have been for a few years now, both in open source and then eventually joining the team full time. So it's something I'm very passionate about.
So it sounds like that worked out for you.
Yeah, in a sense. Australia was nice as well, but I love being here in the States.
Okay. Awesome. Open source is awesome. We've hired a number of folks from out in the community, and that's been super positive. So let's get into the topic. So let's quickly go over Orleans again, maybe 30 seconds, and then what's observability and how does that relate?
Sure thing. So Orleans is a framework for building cloud-native applications on .NET. So any kind of distributed application, you can build that kind of thing using Orleans. And in particular, Orleans has this special kind of a model using distributed objects called grains. And so you model your application using these objects, and then Orleans will handle communication and activation and routing and all those kinds of things.
Yeah, I also understand it handles like serialization too. So like the grains don't all have to be active at one time.
That's right.
Yeah. Super useful for those durability concerns and blah, blah, blah. Mm-hmm. So let's talk about observability then.
Yeah, so we've done a few videos on Orleans now, and today I want to talk about how you implement observability in Orleans. And of course, the first thing that you need to cover then is what is observability? Now, that can be a kind of contentious topic. There's a lot of deep opinions that people have on it. But oftentimes people divide this thing into three main pillars. And so you've got metrics, tracing, or distributed tracing sometimes, and logs. And these are the first things that you'll go to when you're debugging an application. So if you've got a production issue with your application, typically you'll look at these three things first before you start reaching for, let's say, memory dumps, or start trying to attach a debugger to your process in production there. But of course, those are also parts of observability in a sense. And monitoring systems that do alerting also tend to be based upon these kinds of things. So they'll monitor for logs, maybe see exceptions, or maybe they'll see spikes in metrics and things like that. So observability is a very important topic when you're building distributed systems or systems in general.
Yeah, one term that we used to use back in the day, and now I'm kind of thinking back to like 2005, like ages ago, we used to use this term production diagnostics. Mm-hmm. And in a lot of ways, I think we were actually talking about observability, but didn't necessarily have all the right language at that time. Is that fair? Or would you say production diagnostics is really something quite different?
No, I would agree. I think that language has essentially evolved over time. And this whole space, because people are actually starting to move into cloud native apps nowadays, this is becoming much, much more important because you can't just attach a debugger to your entire application. And so people needed to define specific areas of observability and really define those different areas so they can build tooling around it and things like that. It's essentially the same vein, though.
Totally get it. So what do you want to show us?
So I want to talk about observability in .NET to begin with. And you can see how these three pillars map to different concepts here. We're not going to talk too much in detail about logging or metrics, but we're going to focus on tracing because in Orleans, you're building distributed applications, and logs and metrics don't really tend to go over the network directly, or they don't really need any interaction with Orleans in order to be useful. But with tracing, if you're making a call over the network, you need some way of identifying both sides of that call. And so you have to do something special in order to be able to make that trace context flow across the wire from both sides so you can get a full idea of the picture. And what tracing is really is just the ability to see which calls are made and which calls those calls make. So you can get like a full kind of stack trace or rundown of what the application is actually doing. And one of the core things that we're going to look at here is a new technology called OpenTelemetry, which recently hit production or hit 1.0 status.
Yeah, so one of my questions for you was going to be, when I talked to Saurabh on our team, who I assume he often talks about observability, and so I know we added OpenTelemetry support in .NET 5, and I believe it's being extended in .NET 6, and we have all of our own concepts for this. So my question was going to be, does Orleans have its own set of concepts, or how does it relate to the work that Saurabh would be working on?
Well, just like system.diagnostics.activity, Orleans also predates the concepts of OpenTelemetry. And so you need to essentially evolve things over time in order to be able to adapt. And so today we're going to talk about how we can adapt activity and the facilities in Orleans to make use of OpenTelemetry. So yeah, they are complementary, and it's nice that we can have support for the new W3C trace context in activity, which I think is what Saurabh might have been talking about, in order to be able to plumb these things across in a really nice and easy way.
Sounds great.
So I mentioned the W3C trace context. Well, what is that? Essentially, it's a standard for headers, but also for formats for doing distributed tracing. I also mentioned system diagnostics activity. That's the .NET class, which really corresponds to this. So it's a way for tracking operations for tracing and logging, and it supports this W3C trace context standard. But then there's also this system called OpenTelemetry, and that's an open standard that unifies a whole bunch of different other efforts for tracing and metrics and brings them together under one common API and specification. So it talks about conventions and an API for implementing these things. And it recently hit 1.0, and now there is support for integrating with ASP.NET Core. So how does that look in Orleans? So in Orleans, we've got those three pillars again. We're talking about logging, we have metrics, and then tracing. For logging, Orleans uses the Microsoft Extensions logging abstraction. So nothing has to change there. If you're used to logging in .NET, you're probably familiar with the same thing. For counters or metrics, we have started supporting event counters, but most of the code in Orleans is still using something that predates a custom pluggable telemetry interface. Now, as far as tracing is concerned, I mentioned that Orleans predates OpenTelemetry, so we have tools for supporting it and for implementing it. And what we really need there is some way to execute something before and around every single call, and also some way of flowing this tracing context along a call chain. And so we'll talk about those two things in a moment. And so we're going to use those tools to build OpenTelemetry support. And all of this that I'm going to show you today is built on some open source contributions.
So one question I have for you is, back in the day, this is definitely pre-OpenTelemetry. I used to hear the team talking about correlation IDs. And can you talk to me about how that correlation concept that we used to talk about, how it applies to this world, and if it does?
Yeah, so the correlation ID concept was maybe less flexible. It was largely based around having GUIDs that would flow down the call chain. And so the support that Orleans had out of the box was built around that same correlation ID concept. And so you can propagate some GUID that represents this operation along the call chain as well. But the new standard with OpenTelemetry is a bit more flexible. You can attach more context to things. Like, for example, you can attach information about which method is being called. It's an RPC method, what the peer is, and all sorts of metadata, or explicitly call out exceptions and things like that. And so it's a much wider standard for doing all that kind of stuff.
So do you have to, some of that sounds a little bit like ASP.NET view state from this perspective of, like, I could have this bag of all these properties. Do you have to be a little bit careful of not overloading this metadata such that the cost over the wire is high?
So over the wire, you only end up typically sending around a few IDs, but then those IDs are used to string those other things together.
I see.
There'll be collectors or publishers sitting on each of the processes, and they'll be pushing that information out, and then it'll be getting sewn back together. So you do have to be careful still because of allocations, and there's going to be some expense to this. And so most tracing systems have something called sampling, where they'll pick certain traces if they look interesting, for example, and only save those ones to the system. We're not going to talk about that too much today. It's not very Orleans specific, but still, in general, it is something that's expensive. So the first thing that we need to talk about is call filters. So in order to be able to propagate some trace context around a call chain, we need to be able to execute some code. And so call filters give you some way of executing code around a grain call, either on the caller's side with an outgoing grain call filter, or on the target side with an incoming grain call filter. And if you're familiar with ASP.NET Core, they have this iAction filter concept. The call filters in Orleans are very much the same thing. Except that because Orleans makes calls and receives calls, it has two that correspond to each of those things. And so you can inject many of these calls into your application, and then each one will essentially wrap the next one in its chain. So it'll call, do some operation, and then invoke the next caller. And then the last one is going to end up invoking the grain itself. And that might seem a little bit abstract. So we have that in picture form. And here's what it looks like. So in this series, we've been talking about this Hanbaobao Chinese English dictionary app. And so as part of that, it had this dictionary entry grains, and that had a method called getDefinition. And so this is what it might look like if you have a caller on one side calling getDefinition on some grain on the other side, and you've got some call filters configured. So the first thing that happens is that once you make a call, it invokes your first call filter. And in this case, let's say that it's a retries filter. So maybe it'll try invoking and try catch some exceptions or retry if it needs to. But it'll invoke the next call filter and the next call filter, which is, in this case, it's going to add some tracing context information to the call. And then that'll invoke the next thing, which happens to be all of the plumbing that connects your caller and your grain together in Orleans. And so that includes things like routing and serialization and networking. It might end up doing a network hop if this thing is not on the same machine as this one. But then anyway, so it gets to the other side, and then it'll call the incoming call filters. And again, we've got tracing there because it's going to take that tracing context off of the request context object that we're going to talk about in a moment. And it's going to propagate that into an activity from system.diagnostics.activity, and then have that run for the lifetime of the call so it can trace what goes on inside this method. And then maybe you want some logging or maybe fault injection like some teams in Microsoft do if they want to inject faults into random places in their system whenever they want to.
So you might be queasy if I ask this question, but are those call filters similar to like ASP.NET Core middleware?
Yeah, they are very similar. So the closest analogy is the iAction filter in ASP.NET. And they were modeled intentionally to be familiar to people who are used to ASP.NET's iAction filter. So it's very much similar to middleware. You can do the same kinds of things in them.
Makes sense.
Cool. So the next thing, thanks. The next thing we need to look at is the request context. So how do we actually propagate this information across the call chain? So the call filters are going to use this async local dictionary that we have here called request context, and it just has two useful methods. You can get a key or set a key. So you can think of it like HTTP headers you can set on any call, except in this case, they get propagated all the way down the call chain. And so you can use this facility here to propagate information like the authentication or authorization context, which user is making this method call, or in the case that we're doing today, a trace context, or in another example, maybe retry or timeout information. Essentially anything which doesn't fit into a method parameter. So with that stuff out of the way, what we're going to do today in order to implement OpenTelemetry is we're going to create two call filters. One that's going to try to propagate the current activity that's in scope onto the request context, and that'll be an outgoing call filter. And then an incoming call filter that's going to go and pull that information back off the request context and propagate it into the activity. And so then we'll add OpenTelemetry support and view the traces in Zipkin. So here's our solution, and this is the same as what we were looking at previously. This is our Handbell Bow web app, and except here we've added this new class, and this class, hopefully that's large enough for people to see. That class is based on this PR up here that we could link in the notes if we want. And essentially, we've got two filters. One is our outgoing filter that's going to read the current activity and potentially start a new activity if it needs to, otherwise just propagate the existing one. And you can see how it does that here. It's taking the current activity that's in scope, and if we've set to use that W3C trace context, so if we've got the right format in use, then it's going to go and set some headers, trace parent in this case, and trace state here, and it's going to set them on the call, and then it's going to call the next filter in line. So this is what you saw before, where it will invoke some code, call a filter.
I see you're already using C#9 features.
Oh yeah, all over the place here. Yeah, I love pattern matching actually.
Yeah, that's what I was looking at.
And then on the other side of the wire, we've got this incoming call filter, which is just doing the reverse. So it gets these two values off of the request context, and then it's going to pass them into the correct activity context. And this method here goes and starts an activity. So it'll go and propagate that request context, activity context there into an activity. And then at the end, it'll dispose the activity to finish it. But in between here, it's actually going to call either the next filter and eventually that grain method. And if an exception happens, then we can also add some information about what kind of exception happened, etc. And these are all from that OpenTelemetry specification. So these properties are lining up to what that specification said.
So in that one spot on line 3, do you know you could have written it? I know this isn't the topic, but you could have written activity is not null and written as a word. And then I think you could have put in brackets, is all data requested by itself?
Mm-hmm.
Because it's testing the same thing as before. Do you know what I mean?
Oh yeah, exactly. Yeah. So that would look like, oops. This is sitting behind a
exactly. Yeah.
I don't know if I need the true there, but I think so.
I think you do.
You can do something like that.
Yeah, you could have changed it. I don't know.
In fact, you can get rid of not null. You can just say this.
Actually, you're right. Yeah. That's way better.
So this is how we define our two filters that we needed. But then you've got to go and wire them up into Orleans. And so this is the 3 steps that are involved in that. So the first thing you need to do is specify that activity, which is that system.diagnostics.activity type, is going to have to use this new W3C trace format. And that's a program-wide setting. And then the next thing is we use the Orleans builder to go and configure that outgoing and incoming grain call filter.
Okay,
so
like we saw before.
This is the only, sure thing. These are the only Orleans specifics concepts here. But then the next thing is we want to specifically go and configure OpenTelemetry itself. And so into this project, I've pulled in OpenTelemetry and some ASP.NET Core integration packages. And then I'm telling it I want to integrate with ASP.NET Core. I want to add this source for Orleans that we specified up here. We didn't go into it, but we have an activity source that we can define up here that we use to emit our events. And then I'd have to just define 2 exporters. So for development purposes, we have this console exporter, so we can see what the output looks like in the console. But then in another scenario, we might want to use Zipkin. And so you can start Zipkin, which is a tracing dashboard using Docker. So if you've got Docker on Windows, you can just run this command, for example, and that'll launch Zipkin locally and map the port so that you can access it. So without wasting too much time, if I hit F5, I really should have hit Control F5, but.
Yeah, at some point you're going to tell me what Zipkin is.
Yeah, so Zipkin is a tracing dashboard that lets you look at these traces. So OpenTelemetry can send its traces to Zipkin.
Is it
And
built on something like Grafana, or is it's its own thing?
it's its own thing. Yeah, Zipkin is separate from Grafana. And so then we have our trace dashboard. But first, we've just launched our app in Visual Studio. And so if we go and execute some queries and then get rate limited by the application, then we can go and see in Zipkin what that ends up looking like. So we have our requests here, and we can click show on any one of these and see, okay, we've got ASP.NET. It might be a little bit small, but ASP.NET is logging API/search was called, and this call eventually failed. And then that called into this user agent grain with some IP address that ended up throwing an exception. And you can see the exception that was thrown here. It says request rate exceeded, wait 6 seconds before trying again. And if we look at, say, a more complicated trace, maybe this one, you can see that multiple calls were involved. And so you can see all of the different calls that were involved in the call chain. So it's quite simple to end up seeing these things once you've got it integrated.
Right. So that rate limiting, maybe you said this before, but was that implemented as a incoming call filter?
It was actually, and it was implemented in a previous episode on the grain itself. So you can actually just implement this incoming grain call filter on your grain. And then we implemented a leaky bucket filter here that will go and have a throttling score incremented and have a certain decay or like a leak rate. And then it will work out if you're throttled and throw if you are. So it's the same concept. Yeah.
Sounds great.
Yeah, and so that's all I wanted to show you today. So talk about grain call filters, request context, and how you can implement distributed tracing in Orleans.
So one question I have is, so that's all awesome. One question I have is back to the work that like the .NET team does on observability and OpenTelemetry work. Is there any kind of goal for Orleans to kind of have the same feature sets so that they kind of move forward together? How does that work?
Yeah, so thankfully the work that the .NET team has done means that we don't necessarily need to pull in, say, specific open tracing packages, OpenTelemetry packages. Just like in this class here, there's no using directives that refer to OpenTelemetry. So we can implement that all in box without having to pull in specific libraries, and implement like a very smooth OpenTelemetry integration that's up to the user to decide which packages they want, just based on the facilities that are in the box. So activity source, and all of that.
Makes sense. So what about something like dotnet-monitor? So its purpose in life is as like a sidecar container, at least if we're talking about containers, to egress data out. Now, in a distributed system, there wouldn't be like just one place to mount the sidecar. So how would that relate to an Orleans deployment?
So, for example, we use dotnet-monitor in Azure PlayFab on some of the teams. So we have dotnet-monitor deployed as a sidecar in AKS. And so if, for example, you're having some problem, you will find the specific pod that's having a problem and then log into the, not quite log in, but make an HTTP request to the dotnet-monitor sidecar that's on that pod. And for example, you would ask it to perform tracing, or you'll ask it to perform a memory dump or something like that, and then diagnose from there. So usually that's the second port of call. The first thing you'll look at is logs and traces from your telemetry system. And then once you've identified that there's a problem somewhere, and maybe which specific pod it's on, you go and have a look at that pod, and then log in with dotnet-monitor and take some memory dumps and capture some profiling traces, and then go and examine them on your local machine typically. So with VS, for example, you can take those memory dumps from Linux directly and load them up and debug them in memory.
So it's kind of like a concentric circle kind of thing. What we've been discussing today is the inner circle for observability, and then .NET-monitor would be one circle out. Yeah, if that works as an analogy.
They're definitely very much complementary things.
Okay. Awesome. So where should people look if they're using Orleans and want to make sure they're using observability, or maybe they're not using Orleans, and and they like what they saw.
So the first thing is, for the example today, we're looking at this handbaobao-web repository on GitHub. And then for Orleans itself, that's on the .NET/Orleans repository on GitHub. And so you can see it there and have a look, or come and join us in the Gitter chat room at gitter.im/.net/Orleans.
Okay, thanks. Well, thanks thanks for being on the show, and thanks for watching another episode of On.NET.